Yeah, so this will be the worksheet for this lesson. And let's see if and right, so maybe in the meantime, all of you can try question one. Okay, so this is on testing your understanding of the difference between atoms and ions. Okay, so keeping all around and so on. Just remember that atoms, they are neutral, electrically neutral, and so they should have same number of neutral particles, same number of protons and electrons. Yeah, protons, yes. Oh, like, let's see. So, does anyone else not have a copy of this worksheet? Okay, yeah, so can you all work on question one? Yeah, and find out which atom is a noble gas. So underline two keywords in the question. One is atom, meaning the proton and the electron number must be equal. The second is noble gas. What is the special feature of a noble gas? The outermost shell is full. The outermost shell is more stable. Yes. So underline these two keywords, and then I'll be casting this means which one here. Yeah, oh, and also the school would like to remind all of you that there's an inter-school science competition. So I want like 4 of you. Yeah, so you can volunteer. If nobody volunteers, I will nominate. Yeah, so I want the school wants 4 of you to join this science competition. For example, you can build a chemistry volcano. It's in March the 4th. Yeah, so if you're interested, you can come to me after class. Yeah, if somebody is interested, I will have to nominate all persons. Okay, maybe, yeah, for those of you interested in doing this, it's totally up to you what to do. You can make a experimental display. You can do elephant's toothpaste. Have you heard of elephant's toothpaste? Yeah, it's a chemistry experiment. So you have to showcase this to a number of judges, like in principal, okay, from other schools. Yeah, so feel free to come to me and yeah, okay. Maybe I'll pass this around, pass it back to the front later. So yeah, you can walk through all of you. Okay, so now let's work on the question together. Just give it a second. Sorry. So the first question, anyone knows the answer to the first question? Which is an atom? We can already rule out some answers just by looking at the first and the second column. So we can already rule out answers just by looking at the first 2 columns. So which of these is an atom? Which of this can be an atom out of W, X, Y, and Z? Y and Z. Okay, only Y and Z can be atom. But which of these, Y or Z, is also a noble gas? Z. Okay, because the electron arrangement is 2A. Yes, so put this down, please. Okay, so we have, let me go back to the noble gas. Yeah, so later all of you can check on the school classroom for the recording of this lesson and also the lessons to come. So we have number 1, atom, underline the word atom and also the word noble gas. The word atom means the number of protons is the same as the number of electrons. Okay, we have to look for these keywords when we answer questions. Okay, the second thing is underline the word noble gas. Yeah, so abominable gases that they have a full outermost shell. So all things considered, okay, we have option C. Okay, so C is the only option. So C has same number of protons and electrons, and then the electron arrangement is 2, 8, which means it's full. And like I asked one of the students earlier before, a full outermost shell indicates stability. So this is tied to stability. So the answer to question A will be C. But which of these are ions? And I want more. I want you to tell me what kind of ions are they. Are they cations? Are they anions? So which of these particles could be an ion? W and X. Okay. What kind of ion is W? Do you know what the charge is for W? Does it have more protons or more electrons? More electrons. Okay. It has 3 more electrons than protons, which means it has a net charge of yes. So you know protons are plus 1 charge. Yes. Electrons are negative 1 charge. What happens when you add positive 15 to negative 18? It is negative 3. Yes. Okay. So the second question is a little bit more, challenging. So you can understand W and X. They have different number of protons and electrons. So with W, there are 15 protons and 18 electrons. And with X, there's 12 protons and 18 electrons. So if you are struggling to find the charge, you can do the following. You remember that protons are plus 1 charge each. So plus 1 each. And electrons are negative 1 each. Then you can add up these numbers. You have positive 15 added to negative 18. And you know the answer is negative 3. So that means W actually has a 3 minus charge. So you can put that in there. And I want you to all to do the same on X. I want you to tell me what the charge is for X. Okay, so do the math. If you are not too sure, you can use a calculator. In X, you can use a calculator. So what is the charge of X? Anything? Yeah, I see the number 2. But you should include also the sign. Okay, sign plus 2, please. So can you put down positive 12 plus negative 10? Of course, on the calculator it will show 2. But it's important that we put down 2 plus in the exam, as ions are charged. So 2 doesn't cut it. So make sure you indicate a charge. And can you tell me which of this is a cation, which of this is an anion?
W is
Anion, and this is a cation. Which group could they possibly come from? Do you remember that periodic table we drew yesterday? Based on the charge, can you predict which group? For W, given a 3 minus charge, it could come from group 5. Yes, group 5. For those of you not sure which table we are referring to, this one. You see, anytime you see an ion with negative 3 charge, this is a group 3 element. So W is group 3. What about X? X. Group 2. Yes, group 2. Because the 2 plus charge ion indicates that it comes from group 2. Okay? Yeah, so put this down. Although this is not asked by the question. So you can write down the conclusion here is W is from group 5 and X is from group 2. Okay? Great. Now, the rest of the questions you will have to finish it homework. Okay, so this is like a worksheet and you will be graded. Okay, will be graded. So, but then I also want to work on question 2 with you. Okay, together. One of the questions in question 2. So can you all look at the opposite side of the page? We have calcium and oxygen. So yesterday I saw that many of you looked a little bit confused. Okay, when I taught you like the workings of ions, how to draw the ions, how to figure out the number, especially like on this part, the number part. Okay, like the 1 and the 2 you see here, for instance, like here, like the number 1s and the number 2s. Okay, so so today I want to teach you another method to work that out. So the first for this one. Atom, yes. Any question? Okay, yeah. So atoms and ionic compounds have a lot of things in common. Right, yeah. Atoms and ionic compounds have a lot in common. Yes. The data in research time you can come discuss with me if you're interested. Okay, yeah, the four participants. Okay, so atoms and ionic compounds, they are both electrically neutral. So electrically neutral, meaning they are uncharged. Okay, and in the case of atoms, it is the number of protons and the number of electrons being equal in number. And in the case of ionic compounds, it's the total number of positive charge and the total number of negative charge that has to be equal. Yeah, this is why they are both electrically neutral. Okay, so you know protons are positively charged, electrons are negatively charged. The number has to be equal in atom. And in ionic compounds, the total number of positive charge from the ions, the cations, must be equal to the total number of negative charges from the, or I should say, of the anion. Let me show you what I mean by that. You all know sodium chloride. Sodium chloride, what's the formula? NaCl. Okay, and NaCl is actually the sum of two ions. Okay, so you can put down this. Okay, this is the ionic compound. This ionic compound is the sum of two ions. One is Na plus, the other is Cl minus. You can see that the total number of positive charge is actually equal to the total number of negative charge. They're both 1. It's just that one is positive, one is negative. They add up to 0. Okay, this is what electrically neutral. Okay, so they have to add up to 0, the sum of charges. So NaCl is too simple an example. What about other more complicated ones? Like magnesium fluoride maybe? So MgF2. Does anyone remember what the number 2 describes? Does it describe Mg or does it describe F? F. Okay, so that means Mg, knowing that it's from group 2, what is the charge of Mg?
+2.
+2, yeah. So you can put 2 plus in the exam. Okay, yeah, I won't take away points if you write +2 in the beginning. Okay. And knowing that fluoride or fluorine is from group 7, what is the charge of something from group 7?
1 minus.
1 minus, yeah. Okay, so we'll write 1 minus. And in here you see something doesn't add up. It's the charges. The charges, they don't add up to 0. So to fix that, to ensure that ionic compounds, this is the ionic compound, the whole thing, okay, remains electrically neutral, we need to fix the numbers by putting a 2 in here. Now, when we add up these numbers, +2 and 2 times -1, they finally add up back to 0. So this is what the number 1 and 2 here means. So you can put down 1, 1, and 1, and 1, and 2 here. Okay? So far, any questions? No. Let's try an even harder one. Aluminum oxide. Aluminum oxide is the ionic compound found on window frame. You know those window frame you have at home, okay, aluminum window frame. This compound accounts for the grayish, okay, the dull-looking appearance of the window frame. Okay, so this is aluminum oxide. The formula is Al2O3. Can somebody tell me what's the charge of aluminum if it's from group 3? +3, yes, +3. What about oxygen from group 6? -2. So we put this down first. Al3 plus and O2 minus. So before you add those purple numbers in there, maybe some of you will ask, why is it not Al? Why must it be Al2O3? Why can't it be Al1O2, Al2O4, Al4O3? Why must it be Al2O3? That's because when we put the number 2 in front of Al3 plus and 3 in front of O2 minus, can anyone tell me what happens when I multiply the charge? they will both be 6. One is plus 6, the other is negative 6, right? Do you all see this? Yes. So you have 2 times plus 3 and 3 times negative 2. The numbers in purple ensure that, okay, the total charges always add up to 0. Okay, so this is what the purple number do. And this is why the purple number can't be any random number. They have to be in certain ratio. Okay? Yeah, so can you all put this very, very important point down on the side? The subscripts, they are not random. So the subscripts, these are what we mean by the subscripts. So they are not random if you think they are random. Okay, so they are not random. And they are there. Yeah, so they are there to ensure that. So they are there to ensure that the overall ionic compound remains neutral. And on the right is a very, very fast way to figure out these ratio. Okay, yeah, you can plan this very important point at first. And then on the side, I'll teach you a new method called crisscross rule. Crisscross rule allows you to find the formula of the compound in an instant if you know the charges. Okay? Yeah, so let me write this down on the opposite side here. Crisscross rule. You don't have to remember the name of this rule, just know how to apply it. If you know the charge of ions, so if you know the charges of the ions, it allows you to find the formula of the compound. So then you can work out the formula. Yeah, so formula means NaCl, Al2O3, that kind of thing. So okay, you put down NaCl, these are formula, Al2O3 of the compound. By doing this, so write down the general equation. When you have N, A plus, and when you have N, B minus, you just have to take these numbers with your watch. So you see A and B up there, right? Crisscross rule means you cross them like that. You bring this number B over down to the bottom right corner of N, and you bring this number A down to the bottom right corner of N, okay? Which would give you M, B, and A, okay? So M, B, and A. And the interesting thing about this method is that you don't care about the charge. You don't have to bring with you the charge. I mean the sign. You don't have to care about it. Plus and negative, forget about it. Just bring the number over. Okay? So just cross the number part over. Forget about the sign. Okay? So leave the sign behind. Let's try this. This is a very handy method, okay, trust me. And just one additional rule. The second rule is that the number B and A, they are ratio. And with ratio, you need to simplify it when needed. For example, what does the ratio 2 to 2 simplify to? 2 to 2 means 1 to 1, right? What about the number 3 to 6? 1 to 2. So this is how you simplify. Simplify the ratio, so B and A are ratio. So simplify them when you can. Okay, so simplify them if you can. If you cannot, leave it be. Okay, so if you can. Put down a few example of ratio that you need to simplify. Like 2 to 4 means 1 to 2. 2 to 2 means 1 to 1. Like that. Let's try this. Okay, we have some application on the right. Like for example, aluminium and oxygen. So you have aluminium, let me write it in a different color, sorry. So aluminium and oxygen. Oxygen is from group 6. Aluminium is from group 3. By now, you should all be very good at figuring out the charge just by looking at the group number. What is the charge of Al and O respectively?
3 and 2 negative.
3 plus and 2 minus. Yeah, 3 plus and 2 minus. We write it this way first. So can you open that Al3 plus and O2 minus? And can you apply the crisscross rule now? Al203. Al203. So you see, we leave out the sign. Forget about the sign. Plus or minus doesn't matter. But when asked to state the charge, you need to say it. Yeah, so can you cross them over and write down the formula Al203? And of course, you have to write all in the same pen. Okay, don't even think about using different colors. Okay, but here to help you see where the numbers come from, can you do this? So these are the ions. So you have cation, you have anion. So these are the atoms. These atoms become the cations and anions. And when the anions and cations they combine, they attract one another. They form the so-called ionic compound. So you see. So that means in the atom state, they were unstable. In the ion state, they are stable. Okay, so these are stable because they all have a full shell, and these were all unstable. So that's the first example. And I want you to try. I think I have another example. Question 6. Can you all refer to question 6? So this is a very quick concept check question. An atom of element X has 19 protons, 18 neutrons, and 19 electrons. Yeah, while an atom of Y has 8 protons, 7 neutrons, and 8 electrons. Which of the following ionic compound do these elements form? You will first have to figure out the electronic arrangement. So I will give you all 30 seconds. Figure out the electron. We are on question 6. Okay, everyone can do question 6 on the worksheet. Okay? If atom X has 19 protons and atom Y has 8 protons, what are the electron arrangement? And once you figure out the electron arrangement, figure out the group number. Once you figure out the group number, figure out the charge. You have 30 seconds. Okay, so work on this question. You can discuss with your classmates. That's okay if you want. Okay, but we will check the answer. We are on question 6. So that's some clues on the board here. Remember atomic number. Okay? And by the way, we'll have a test in maybe next week. After you all prepare for the test. Yeah, I hope that you have been doing revision. Okay? So yeah, I will arrange the test next week. Maybe a double lesson. Okay, because when I did the test for form 5 in a single lesson, first of all, the students will not all hear when the bell rings, which means they don't get enough time to finish the test. So I'll try to arrange it in double lesson. So half of the lesson, the first lesson on test, second lesson teach. Okay? Yeah, so next week, double lesson. Tuesday, right? We have double lesson Tuesday. Yeah, mark it on the calendar. Tuesday. A test on planet Earth. So test on planet Earth. Okay, we are on the second main topic now, like worldwide. So, okay, let's start. We have atomic number 19 and atomic number 8. These are proton number, which means they are also atomic number. Okay, and they will see. Can anyone tell me what's the electron arrangement of X? 2881. Yeah, so 2881. Which group does it be from? Group 1. What charge does it carry? Positive 1. Yes. Okay, so write down your logical deduction. From the atomic number 19, you can figure out the electron arrangement. From the electron arrangement, you can figure out that it belongs to group 1. The period doesn't concern you, so you can put it down in here. Which period is it from? 4. What period number means the number of shells. Okay, so period 4. But that is not required for the question. So group 1 means it has a charge of positive 1. Or just 1 positive, or just positive. What about Y? What is the electron arrangement of link the relation between them, but yeah, in time, okay, you do it. You get to the answer in a second. So this is in period 2, which means it has a charge of 2 minus. Can you all now apply crisscross rule? Crisscross rule. I want to see what happens when you break the number over. If you don't see anything, it means it's 1. If you carry just the number part alone, remember what I said, leave out the signs. Don't worry about the plus and the negative sign. You don't have to look at it, only look at the number part. What is the formula?
X to Y.
X to Y, which means the answer is C. C. Okay, so for question 6, the answer is C. Is it all clear? Okay, let's verify the answer. Okay, I know some students when they figure out the answer here, they are not too sure about the answer. How do we know that this is the correct answer? We try to sum up the charges. We know X is 1 plus charge. And you know Y is 2 negative charge. So you have Y, 2 negative charge. From the subscript, you know there's 2 X plus ion and 1 Y2 minus ion. So what is the total sum of charges? So the sum of charges here is 0, right? Yeah, because 2 times plus 1 and 1 times negative 2 equals 0, right? Yeah, so that means it is neutral. It means it is electrically, yes. Okay, so electrically neutral. Does everyone get me? Yes? Yes? Okay, great. So then we have to look at something more complicated. Okay, yeah, it gets more complicated. So this is so there are other things on this worksheet I want you to remember. Next up, so after this is done, let's try another example in here. What about calcium and oxygen? So calcium is from group 2 this time. Oxygen continues to be from group 6, of course. That means calcium will form a charge of 2 plus, yeah, and O would form a charge of 2 minus. Be careful this time. You have to apply rule number 2. Rule number 2 says whenever you can simplify the ratio, simplify them. So can you cross the number over and tell me what you get? So the first instant you cross the number over, what do you get? You get CA2O2. So the number ratio 2 to 2 can be simplified as 1 to 1, right? 2 to 2 means 1 to 1. So at first, yeah, you can write CA2O2, but then because the number ratio 2 to 2 is simplified to 1 and 1, yeah, so you 1 to 1. Therefore, you will write CaO instead. This is your final answer. This is not your answer. You have to leave your answer as CaO. Yeah, whenever you can simplify. Why didn't we do this earlier? This is because 2 to 3. Can the number ratio 2 to 3 be simplified any further? No. This is why it's okay when we leave the answer like that. But in here, yeah, don't let me see CaO2 on your answer later for our next test. Okay, I mean not next Tuesday's test. Yeah, for the test, you can't leave your answer as CaO2 because 2 to 2 can be simplified to 1 to 1. You have to change them back to 1. Okay? Right, that's tricky. Now I'll give you just one more question for you to try right now. What about aluminium and nitrogen? So I'll give you the group number. Aluminium is from group 3, nitrogen is from group 5. So you all have 30 seconds to figure out the formula of the ionic compound. So I want the answer here for Al and N. ALN? Oh, that's quick. Does everyone know why it's ALN? Why not Al3N3? That's because Al, knowing that it's from group 3, it will be 3 plus charge. And N from group 5 will be 3 minus charge. At first, yes, you will get Al3N3. But knowing that 3 to 3 just like 2 to 2, can be simplified to 1 and 1. We will have the answer ALN. Can everyone follow? Yes. So this is why I really love this method. I call this principle. You don't even need to know the name. Just know how to apply it. Okay. I won't ask you what is the name of this. No, that's not on the test. Okay. But how to apply it, that's what is on the test. Okay. So AL3 and 3. Put down the wrong answer here, as we can simplify it as ALN. Okay. Now, we need to look at more complicated ions. The ions that we have considered so far, they are called monoatomic ions, or they are called simple ions. That's because each of them has only one atom. Not sure if you noticed. In Al3 plus, there's only one Al atom. In N3 there's only one N atom. Are there other ions that contain more than one type of atom? Unfortunately, they are. We call these polyatomic ions. So I want you all to put this on the next page. So we will look at types of ions. So just know that ions are charged particles. So ions are charged particles. But then there are two types of charged ions. One is called the monoatomic ions or simple ions. So you can put down two types of ions. They are, the first one we call it the simple, or I like to call them monoatomic. Mono means one, atomic of course means one atom. Okay, there's only one atom per ion. Simple ion. We have also polyatomic ions. These ions, they contain more than one atom each. Okay, so each ion has just one atom. And on the right, each ion has more than one atom. So each ion has more than one atom. For example, okay, let's just put that down. We have Na plus, Mg2 plus, Al3 plus. Don't be confused. The number on top is not the number of ions or not the number of atoms. The number on top is the charge. So even though you see the number 1, 2, and 3 here, they are all still monoatomic ions. Because we look at what? We look at this part. If you see just a single atom in here, they are monoatomic. Don't be fooled by the charge. The charge is not the number. The charge is the charge. It tells you, how much positive, how much negative it is. Okay, don't be confused. So this is one atom, one Na atom. This has one Mg atom. This has one Al atom. And the reminder here is, don't let the charge distract you. The charge has nothing to do with the number of the atom. Okay? So this is the charge. So we have 1, 2, and 3. These are the charges. Don't let the charge distract you. Now, we look at polyatomic ions, and then you will know why I said the charges are not really numbers. We have NH4 plus. We have I don't know, like maybe OH minus, CO3 2 minus. So these things in here, you see, definitely they contain more than one atom. Let's count together. How many atoms are there in NH4 plus?
5.
5. 1 N and 4 H's. Okay, so can you put that? This has 1 N and 4 H, which means 5 atoms in total. Similarly, how many atoms are there in CO3 2 minus? How many atoms are there in CO3 2 minus? How many? What do you think the formula We call them polyatomic ion. And you know what's the worst thing about this chapter? Is that you have a long list of ions. Remember, if you read the textbook, maybe you already came across that page. That's the worst nightmare of any chemistry students. Okay, you need to remember not just the name, but the formula of all these polyatomic ions. But yeah, not all hopes are lost. Okay, so for simple atomic ions, though, you don't have to remember any of them. That's because the charge is related to group number, right? Remember, the charge is related to group number. So put this down under just the simple ions. I don't want you to mix it up with polyatomic ions. For these ions on the left, we can predict their charges. Okay, so we can predict their charges from the group number. So from the group number, we already saw how this is done earlier. So if the group number is 1, 2, 3, 4, 5, 6, 7, 0, then the charges will be plus 1, plus 2, plus 3. We skip group 4. And I remember one student asked me why are there other ways to become stable. Yes, this is how group 4 becomes stable. They become stable by other ways, other than forming ions. Okay, so cross here means they do not form ions. They do not generally form ions. We have -3, -2, -1, and group 0 we put a cross here again. They don't need to form ions because they are stable. So you can easily predict the charge of any monoatomic ion using the group number, using just the group number. So for example, if you see Mg from group 2, instantly you know it was a 2 plus charge. You don't even have to remember it because the periodic table I will give it to you in the exam. In DSC, they will give it to you. Okay? So you just have to, this is the only thing you need to remember. Okay? When I say you need to remember it, you really have to remember. It will appear in the test. Okay, I told you. Polyatomic ions, unfortunately. Okay, you have to remember them all by heart. Okay, so can you draw out this table for me of polyatomic ions that are positively charged and negatively charged? So we have +1, -1, -2, and -3. Okay, so this list of ions you need to remember all of them. So you have NH4+, which we call ammonium ion. Yeah, so ammonium ion. Try to remember 5 every day. Then in a week you will remember all of them. Okay, so this is called ammonium. And then for -1, we have OH minus, HCO3 minus, NO2 minus, NO3 minus, MNO4 minus. Yeah, I'll bore myself, okay, writing all of them down. Okay, so but you have to remember them. So starting from the top, we have hydroxide, so hydroxide ion, hydrogen carbonate. Yeah, have you tried adding those fizzy drinking tablet into water? The fizzy drinking tablet. Yeah, that's hydrogen carbonate ion. Okay, reacting with acid to form the bubbles. Yeah, so and hydroxide ion is responsible for the corrosiveness of drain cleaner. Have you tried putting drain cleaner into the toilet? Yeah, it will eat its way through whatever is clogging the drain, right? That's hydroxide ion. That's hydroxide ion doing the eating through thing, okay? And then we have nitrite. So this is nitrite. I would suggest that you pay attention to these two. Nitrite and nitrate, they sound very similar. They also spell very similarly. They only differ in one letter. Okay, so I suggest you be careful when you do revision on this. Nitrite is NO2 minus ion. Nitrate is NO3 minus. Yeah, so and then we have a nitrate, by the way, is in fertilizer. So you know if you apply chemical fertilizer to maybe some of your garden plants or maybe some house plants, that's nitrate that you are adding. And then we have this one here. This is a very beautifully colored ion. It's permanganate. But the name is not so beautiful though. Okay, it's very long. Okay, but this is a very beautiful color. It's purple in color. Yeah, and you need to know also the color later. to around your interest, you can put down where they are from. Yeah, but that's optional. If you don't want it, you can just leave these things. Okay, so these are train unblocker. So this is in fizzy tablet. Nitrate. I can't think of a simple household substance with nitrate. Nitrate you can find in fertilizer. Permanganate you only find in the leftovers thing. But sulfite you can find it in dry fruits as a preservative. And some students who have asthma, you may be allergic to sulfite. So make sure you read the label. Yeah, just like some students may be allergic to peanuts. Some students may be allergic to sulfite. Okay, so if you have asthma, pay attention to the packaging of the dry fruits. So, tidy up your notes first. I'll discuss with the ID to see what the problem is because I updated the software. So, just 1 second. Okay, great. Let's continue. So we have carbonate, sulfate, and -3 charged ions, which includes PO4 3 minus, and I almost forgot some of the negative charged ions, ClO4 2 minus, Cl2O7 2 minus. So you need to remember both the charge and also the number of atoms, unfortunately. So put down the name, please. So this is chromate, and this is dichromate. So the easy way to remember chromate and dichromate is to look at how many Cl there are. If you have only one Cl, it's chromate. If you have two Cl, you have dichromate. That's what di means. Di means two. Okay, yeah, tri means three. Okay, we don't have anything to try just yet in this chapter. We have phosphate. Yeah, there is actually a table for this on the, I mean, you mean your table, a summary table. Yes, it's on the textbook. Yeah, so if you can't find it, I will paste one on to here. Okay. Yeah, but you have to remember it. Okay, the whole table, very set. So you have -1 charged ions, -2 charged ions, and so we have also -3, so -3 charged ions, right, like that. So these are called the atomic ions, okay? Now, what is it that we need to know, okay, other than the formula, is how we write the chemical formula of the ionic compound. So can you put this down on the top right hand corner of the opposite side of the book? So deducing the formula of ionic compounds. So ionic compounds, they are made of two parts, the cation and the anion. So you have the cation and the anion. Together, they fit together like puzzle. The whole thing, we call it the ionic compound. The whole thing. Ionic compound is made of cation and anion. So the whole thing, we call it ionic compound. Some examples. We can have Na plus forming a bond with Cl minus. Yeah, so then we have NaCl. We can have, I kind of like this analogy, or you can say, analogy, okay, used by the book, okay. Think of cation as like something with a depression. Okay, you see there's a hole in cation. We say they have a hole because they are short of the electrons. They have few electrons. Anions, they have something that looks like a pointy stuff in here. That means they have extra electrons. They are formed by gaining electrons. What happens when you try to form bond with something with two holes, like magnesium ion? Would one chloride ion be sufficient to fit that? How many chloride would you need? 2. This is why I really like this, very visual way of understanding the relation. One chloride won't get the job done. You need 2 chlorides in there, fit in there. Which is why we have MgCl2. This is why we write MgCl2. So can you put this down? MgCl2. Remember the 2 means there has to be 2 chloride for every 1 magnesium. Yeah, no need to do this for NaCl though, because they already fit perfectly into one another. And of course, like you saw, we can have 3 plus charge ion. What about something with 3 plus charge? Like Al3 plus. Well, they have 3 holes. Okay, so you see they have 3 holes in there. 1, 2, 3. Yeah, but of course I don't recommend that you use this in exam. It's not visual art class. Okay, yeah, so if you like to visualize that, you can draw this. But this is a waste of time in the exam. But here I want to still show you this to help you visualize it. What about Al3 plus and O2 minus? How many of each do you think we'll need in order to have everything fit nicely onto one another?
Al2O3.
Yes, Al2O3. Yeah, so you can draw this out on the side. 1 Al is not enough. 2 O is also like maybe not enough. But when you have 2 Al3 plus and you have like this. So you can see Al2O3, right? Yeah, so this is a very visual way, okay, to understand the relationship. So you can put down Al2O3, and it gets more complicated. What about calcium phosphate? We mentioned earlier. Calcium is from group 2, which means there's 2 holes in there. Yeah, so Ca is from group 2, so Ca2 plus. Phosphate, does anyone remember phosphate from a while ago? What charge does it carry? You can look at your notes. -3 charge. Phosphate is -3 charge. So that means how do they fit onto one another? How can I fit phosphate onto calcium? How will I make it work? two of the Al, the PO4 free lines. Ta-da, you see, it's fixed. Of course, in exam, I said, don't use this method. You don't have so much space to draw so many things. This is what you do, crisscross rule, remember? You have Ca2 plus and PO4 free lines. So you can write down the two methods. The method on the left is the visual method, which is called, first, like for those of you who first learn chemistry. The method on the right, we call it crisscross rule. Why don't we apply it? So crisscross rule. So we have 2 and 3, we swap them. What do we get? We have Ca3. Oh, be careful now. If you have a polyatomic ion, you need to use a bracket. Because the number 2, when it goes here, if you don't put any bracket here, it will look odd. Trust me, it will be PO42, right? You don't need that, right? You don't need PO42, right? So to avoid confusion, we write PO4 bracket 2. Do you get it? Yeah, it takes some getting used to, I know, but you will have to try. Okay. Okay, you put this on top as well. What we did, get this. We have Al3 plus, so we take the 3 with us, then we take the 2 with us, and we have Al2. Now, I want you all to try, like maybe this one here. Oh, okay, now I have some other ions to discuss with you. There are other ions that when you look at question 4, you see there are ions with Roman numbers behind them. Why is that? Because they are the transition metals. Okay, so some metals. So, for example, in the transition metal family, what are the transition metals? Transition metals are between group 2 and 3. Remember there's a gap between group 2 and 3, right? That rectangular block is where you find the top. They go back to, I think, 2 to 3 pages ago. This very interesting family of elements, we call them transition metals. They are between group 2 and 3. We call them transition metals, and this is to distinguish them from the normal metals, from the group 1 alkaline metals and the group 2 alkaline earth. In that they are harder, they are denser. When you put an iron block into water, it sinks. When you try to use a hammer to hit a piece of iron, it's tougher compared to group 1. Remember how soft group 1 metals are? They can be cut with knives, right? Yeah, and they are also they have pretty low density, so they float. So we call them transition metal to distinguish them from the group 1 alkaline metal and group 2 alkaline earths. Okay, they are different, they have unique properties. And so now, I want you to put down some metals in the transition metal family. Yeah, and some from group 4, such as lead and tin. So lead. Remember pencil lead is not lead. What is pencil lead? Graphite. Okay, yeah. Remember pencil lead is not lead. Okay, it's graphite. But here I'm really referring to the element that is the metal. Okay. So tin, food tin. Okay, they are made of tin. Okay, because tin iron is non-toxic. So even if some of the tin metal get into your food, you won't die. Okay. But if you use lead to make food tin, then maybe you will have some nervous system damage, okay, after eating those food cans for a long time. Write down the symbols of lead and tin. Pb for lead, Sn for tin. Yet they are capable of forming more than one ions. Okay, so this is why it's some, not all. Some metals, okay, from these two families can form ions with more than one possible charge. So more than one possible charge. To complicate things, okay, for example, when I say for example, you need to know all of the following examples. Okay, so you have iron. So you all know iron is Fe, right? Fe is symbol. It can form two possible ions, Fe2 plus, Fe3 plus. that means you can lose either 2 electrons to become Fe2 plus, or you can lose 3 electrons to become Fe3 plus. They are all possible. And to distinguish between these two ions, we call this iron 2 ion. The charge will be written in Roman number to not confuse anyone. So we have iron 3 for Fe3 plus. Yeah, just like I'm not sure if there are 2 students with the same name in this class. Are there 2 students with the same name in this class? Yes. Oh, same name. Okay, so then when the teacher said, can maybe what was your name? There are 2 names. Okay. So say for example, if 2 students are both named Alice, then when I say Alice, please answer the question. Maybe 2 Alice will be stand out, right? So to avoid confusion, we'll call them maybe Alice the second and Alice the third. Yes, kind of like that. So you can write down iron 2, iron 3, and then we have copper. So copper, Cu, can form Cu1 plus, Cu2 plus. So we have copper 1, copper 2, and also mercury. Okay, so mercury, which has central Hg. Okay, it can be Hg1 or Hg2. They look totally random. Yeah, and indeed they are quite random, the numbers. Okay, sometimes it's plus 2, sometimes plus 3, sometimes plus 1 plus 2, sometimes plus 1 plus 2. Okay, so there's no easy way to remember that. It's facts. So you have mercury 1 and mercury 2. Okay, so this is why don't be too surprised when you see these things in the question form. If you want to answer question, look at question 4 right now. We have lithium chloride. Let's work on the 4 number questions in here. A, C, E, G, I. Let's work on this together now. Use the periodic table. Okay, do you all have a periodic table with you? Yeah, if you don't, you can use the one on the textbook. Let's work on question 4 on this worksheet together. So we have, here's the formula of the following compounds. Okay, so we have lithium chloride. Okay, remember what I said yesterday? Most of the time when you name compounds or an atomic ion, you change the suffix of the second element to I, right? It takes some time getting used to like how you remember present and past tense in English. So go with went, collected, okay, in here you do the same. You just change chlorine to chloride. Same thing, okay. We have lithium from group 1. What is the charge of something from group 1? 1 plus. Yeah, 1 plus. What is something from group 7 then? 1 minus. It's 1 minus. Okay, 1 minus. Okay. When you do crisscross rule, what do you get? Remember, if you don't see a number, it means the number is 1. So what is the formula? LICL, very good. Okay, you should not include 1 in your answer because 1 is understood. When you say LI1CL1, it means LICL. So that's how you convert the name into the formula. So starting with the next example, I want you all to try. But I welcome you to refer back to the table because nitrate, I said to tell you that it's not the periodic table nitrate. None of the polyatomic ions are on the periodic table. So you need to remember that. So this is the formula iron-free hydroxide and barium sulfate. Yeah, so for barium, you can look it up on the periodic table. This is from group 2, I tell you. So it is from group 2, but the rest, you are not know. So barium is from group 2, that's why I can tell you. Sulfate, you need to remember it, or you can look up the notes. Yeah, in this current stage, you can look at the notes. But in the exam, let me remind you that the table will not be given to you. The table will be atomic ions. So try to remember 5 every day. Then, but by week you remember all of them. So what is the, think about what's the charge of something from group 2 and find something from the previous page. Pair them together using crisscross rule. That's key. Okay? So you use crisscross rule. So any answers for the first one? Iron-free hydroxide. So first you will need to figure out the symbol iron. And then from the Roman number you will know its charge. What is iron-free? Can you translate this into a formula? Fe3 plus, yes. What about hydroxide? OH minus, yes. Now do crisscross rule. Remember what I said again. You might need a bracket. You might need a bracket outside the polyatomic ion. So let's see what happens. What should I write? FeOH, Fe bracket, OH. Yeah, okay. Let me write down another thing in here so all of you remember. When do we need a bracket? You will need a bracket. Why do you not need a bracket here? You do not need a bracket if the number outside the polyatomic ion is 1. Because you will need a bracket if the number outside the polyatomic ion is not 1. Okay, so you can put this in here. Why is there no bracket with that? What do you have in mind? So, no need for bracket if the if the number outside the polyatomic ion, okay, yeah, so no need to include a bracket outside the polyatomic ion if the number is 1. So if the number is 1, which is the case here, you will need a bracket if the number outside is not 1. Yeah, which is 3 here, okay? So include a bracket, yeah, if the number is not 1. This is not 1. Okay, so you include a bracket. So very quickly, let's also work out the last one. Sulfate. Does anyone remember sulfate? What is the charge? -2. There's only one positive polyatomic ion. You can check. It's Na4 plus. All of the other polyatomic ions are negatively charged. Okay? Yeah, so yeah, there's only one positive polyatomic ion. So we have Ba2 plus and SO4 2 minus. What is the formula? Just Ba. Yeah, at first you may write Ba2 SO4 2, but once you figure out that those ratios can be simplified further, you will write just BaSO4. Yeah, so therefore this is wrong and this is right. Is it clear? Yes. Yes. So I want you all to finish up to question 4 only, up to question 4. Yeah, and then we'll deal with the rest. So, question 1 to question 4.
What have you been blocking the camera the entire time?
Wait, did he actually? Is it two?
It's been 21 hours.
Blocking the camera.
This is serious.
I think I'm short. Can William just sit here?
Is it blocking the screen? Can you sit down?
Sir! No way! It was blocking. William was blocking it.
Oh, no, I made sure it's